Right, but okay. Good morning, everyone. How was your weekend? Though medyo mukhang belated na yung tanong kasi Tuesday na nga pala ngayon, ano? So, yeah, I hope you had a good one and you had some time to think about homework number three. Sorry, late ko siyang na-upload. I think Friday ko na siya na-upload, Friday afternoon or Friday evening. I was not feeling well the last 2 days of the work week and then nagpahinga na lang buong almost the entire weekend. So, kaya medyo natagalan. But the deadline for homework number three, tama nga ba? Later tonight pa, no? Sana tama yung nalagay ko kay Canvas. So, and do you think that is a better timing, especially for those na nagwa 155? Kasi may mga nag-request din, sorry, nagwa 175. Kasi sa Math 175, every Monday meron silang pinapasang laboratory exercise and medyo nagsasabay with our stuff. So will it be okay if we move or if we move our time the timing of our homeworks? I'll give it on Fridays, and then you'll have to submit it Tuesday right before midnight. Okay? So para ma-accommodate yung mga nagwa 175. All right. So hindi ko pa nasisimulan checkan yung homework number three, but I hope you are not having big problems on it. So uh, again, no proofs are required. Were required there. So parang wala rin akong hininging explanations, no. Basta bigyan nyo lang yung mga hinihingi ko doon. What is a closure? Ano pa nga ba doon? Yeah, mga simpleng tanong lang naman about a particular set, right? So think about those. No justifications required. Yun nga lang, maging all or nothing siya. All right. So just be very careful. Think about it. So yeah. And then what else? All right. The Institute of Mathematical Sciences and Physics, biglang naging formal, no? IMSP, will be celebrating its anniversary starting, I think, next week. It's our anniversary as a National Center of Excellence in the Basic Sciences. We are just one of the few NCOEs in the Philippines. We're one of seven. Tapos tatlo doon ay nasa UPLB. And it was great. It's not just a recognition, but it was a statutory declaration by the President of the Philippines. So it's a big deal for IMSP. So we are holding several activities to celebrate it. And I think on Monday, we will have the student, faculty, and alumni summit or conference. So I hope you guys can find some time to attend it. So yun yung sa Monday. So if you will attend it, I'll just ask you to write a short reflection paper or a short reaction paper. No formats, no guide questions. So your honest opinion or reflection on what was or what transpired during that particular event. So I'll give you some bonus points for the upcoming problem set for that. Pero huwag kayong mag-expect ng super laki. So, konti lang. So, kaya huwag kayong sumulat ng novela. Okay? One page, even half a page would be fine. Okay? And then on the 28th, meron pang isang event. Again, that's another Monday. It would be the IMSP research webinars. So, ito naman ay magiging tampok yung iba't ibang research clusters in the math division or IMSP also. So, kasama yung physics. But I would like you to pay more attention to the mathematics research clusters, especially if you're still deciding what specialization to pursue. So kung wala pa kayo naiisip na special problem or thesis topic, wala pa kayo nakakausap na advisor, so that would be a good opportunity for you to have an idea kung saan kayo pupunta during your senior year pag gagawin nyo na yung undergraduate research nyo. So all of the research clusters will be presenting something. So you might want to check it out. So, and then I'll be asking you to write a reflection paper again for that to get some bonus points for the upcoming problem set. Pero yung sa research webinar, I want you to write something about two clusters that caught your attention or that you got interested in, all right? So, dalawa kasi syempre una, kung meron na kayong naiisip na major, so yun na yung bias nyo. So, ibig sabihin talaga makikinig kayo dun sa kanilang presentation. So, for instance, if you're into actuarial science, so you will be more likely interested to hear and to react to what the FMAS guys will be presenting, right? But since we want to cultivate the sense of cross-disciplinarity among our students, hindi tayong nakakahon lang sa isang particular field of specialization. So it is also good to have a feeling of what others are doing so that we can collaborate, we can talk about common grounds or common problems, or yung problems natin, kaya nating ipasolve using the methods of other guys, or we might have some tools that we can offer to other people working in other fields. So it would be a nice scientific collaboration. So yon, kaya kailangan pa ng isang research area or isang research cluster na magre-react kayo. So at least 2 research clusters yung isusulat nyo dun sa second reaction paper. Okay? And then there is another one, another event. I think it's the job fair, but that is I think that would be kailan nga ba yun? I forgot the date, but definitely that would be another Monday after the 28th. I'm not sure if it is the Monday right after 28th or the Monday after that. So check ko na lang yung calendar later. But I won't ask you to write a reaction paper for that kasi job fair naman siya. So if you guys are already in your senior year, expected to graduate this coming semester, or if you are if you're looking for internships during the summer or during the mid-year term, so you might want to attend that job fair. Okay. So yun, I think those are our housekeeping matters. Okay, so let's go back to business. So ano nga bang ginagawa natin last time? Oh, last time pinag-aralan natin ano yung mga limit points, right? So when we say limit points, these are points where the elements of the set accumulates, right? So ito yung mga points kung saan nagkukumpul-kumpul yung mga elements nung isang particular set. And the collection of all limit points of a set A is called the derived set of the set A. So pag sinulat natin X element of A prime, that means X is a limit point of the set A, meaning elements of the set A gather around the element X. And again, the number X is not necessarily a member of capital A. Dapat lamang nagkukumpul-kumpulan yung mga miyembro ni capital A sa paligid ni element X. So how do we characterize nagkukumpulan, or what do we say when what do we mean when we say elements of A gather around the element X? Mathematically speaking, we say that for all epsilon greater than 0, okay, sa kahit anong epsilon neighborhood, however small, centered at X, okay, there exists an element Y, okay, different from X, such that Y is a member of the intersection between the epsilon neighborhood of X and the set A itself, all right? So ibig sabihin, you need to find one guy, at least one guy, different from X, such that that Y belongs to both the neighborhood of X and dun sa element A. So ibig sabihin, makakita ka ng element ni capital A na naninirahan malapit kay X. All right? And this is how we quantify it. You should be able to find such an element Y sa kahit na maliit na neighborhood lamang ni X. All right? So that's what we mean by being a limit point. Now, if a set, if X is in A, but X is not in the derived set, so ibig sabihin si X ay miyembro ni A, pero si X ay hindi limit point, then we say X is an isolated point. Okay? So ito pa yung isa sa mga pinag-discussionan natin. And I think we stopped when we talk about the closure of the set A. We define the closure of the set A to be the union of the set A itself and the set of all of its limit points. So the closure is denoted by A bar, okay? And it is basically A union A prime being the derived set or the set of all limit points of the set A, all right? And I think we were about to prove a nice property of the closure of a set. Yun yung nasa theorem 1.13. But I hope you guys understand the concept of the limit point. Hopefully, na-visualize nyo siya. Tapos tandaan nyo itong definition na to. Kasi ito yung paglalaroan ko ng ilang beses dun sa mga proofs na makikita natin. Alright? So, dapat si X na limit point, siya yung nasa loob ng epsilon neighborhood na nandun sa intersection. Tapos meron kang element na different from X na miyembro noong epsilon neighborhood at saka nung set itself. Alright? So, I hope you won't be confused when I write this every time. Kaya mas magandang verbally siya ginagawa or habang sinusulat niyo siya, verbally niyo siya sinasabi para nag-guide kung ano yung isusulat niyo. Kasi kung sasauluhin niyo lang to, unless you have a very sharp memory, then madaling ma-jumble yung mga letters o yung mga variables dito sa phrase na ito. All right? So be careful about that. Okay. Now, what is that nice property of the closure of a set that I was alluding to earlier? Well, that's theorem 13. And what does it say? So the closure, A bar, is actually a closed set. And not just that, it is the smallest closed set containing capital A. Right? So itong theorem 13, it has two parts. Una, kailangan nating ipakita na si A bar ay isang closed set. Okay? Tapos pangalawa, wala nang closed set na mas maliit pa kay A bar na nagko-contain kay A. Alright? So basically, it's the smallest closed set containing A. So we'll divide the proof into two parts kasi independent yung dalawang statements. So first, we'll prove we want to show that A bar is closed. Okay, so we want to show that A bar is a closed subset of R. And again, when we want to show that a certain set is a closed set, we want to show that it contains all of its limit points. All right? Dapat laman niya lahat ng kanyang mga limit points. All right? So ang gagawin ko, magko-consider ako ng isang limit point ni A bar. And again, pay attention. I am taking a limit point of A bar. All right. So I will let, say, X be a limit point of A bar. All right. So ibig sabihin, nandun siya sa derived set ni A bar. Okay. Or if you want, kung medyo hindi kayo comfortable sumulat ng maraming symbols, so you can say let X be a limit point of A bar. And our goal is to show that this arbitrary limit point of A bar belongs to A bar. Gusto kong ipakita that X is in A bar. Kasi pag napakita ko na si X ay na kay A bar, ibig sabihin lahat na ng limit points ay na kay A bar. Okay, lahat ng kanyang limit points ay nasa sarili niya. Meaning, it is really closed. All right? So, what can we say about X being a limit point of A bar? So that means, gagamitin ko lang yung definition ng pagiging limit point ni X. So this means, so there exists a Y different from X such that Y is a member of the epsilon neighborhood of X intersection, okay? Limit point siya nino? Limit point siya ni A bar. All right? Again, the claim is that X is a limit point of A bar. So therefore, sa kahit anong or kahit gaano kaliit na neighborhood ni X, merong member na Y na naninirahan doon na nandun din kay A bar. May member si A bar na naninirahan doon sa maliit na neighborhood ni X. Right? Tapos, gagamitin ko yung definition ng A bar. All right. So because the only thing we know about the closure so far is that it is A union A prime. Tapos parang yun na lang yung pwede kong gamitin dito so far. All right. So ibig sabihin, pwede kong sabihin, that's equivalent to saying that Y is an element of this intersection. A union A prime. All right. But again, pwede nyo isulat dito, ano nga ba yung goal natin? Gusto ko ultimately ipakita na si X ay nakay A bar. All right? Kasi si X ay arbitrary limit point. I want to show that A bar is closed. So I want that arbitrary limit point to belong to the set A bar itself. Pag napakita mo na si X ay na kay A bar, then we're sure that A bar is closed. All right? Tapos, okay, so far meron na ako nito. parang a natural thing to do is to use the distributive laws for intersection over unions, right? So by properties na natutunan nyo sa Math 101, so this means Y is an element of this this set. So this would be the epsilon neighborhood intersection A. Tapos yung sagot doon, i-union ko sa epsilon neighborhood intersection derived set. Okay, so just a play on set operations. Okay, and then what does the what does the union operation translate into? So remember, ang union signifies a disjunction. So pag sinabi nating si Y ay element nitong set 1, union set 2, ibig sabihin either Y belongs to set 1 or Y belongs to set 2. So ibig sabihin, kailangan kong hatiin ito sa dalawang cases kasi may dalawang posibilidad kung saan naninirahan si Y. Si Y pwedeng dito nakatira or pwedeng dito siya nakatira sa kabila. But we cannot say for certain or we don't have any other information about Y, so hindi ko alam exactly kanino sa dalawang sets na yan naninirahan si Y. Okay? So ang alam ko lang, at least may isa sa dalawang sets na yan kung saan naninirahan si Y kasi nga naka-union. Element siya ng union, so element siya nung at least isa sa kanila. But we want to build a proof without any holes. So ibig sabihin kailangan ma-cover natin lahat ng possible cases. All right? So that's why I'm gonna split this up into two cases. I'll consider case 1. The case that what if Y is an element of the epsilon neighborhood intersection A. Okay? Kung si Y ay element ng epsilon neighborhood intersection A, ano yung pwede nating masabi? Sige nga. So what can we conclude from that statement? Kasama dyan yung mga prefatory statements on kalimutan ko pala yung for all epsilon, sorry. So for all epsilon, so basically what case 1 is telling us, for all epsilon greater than 0, there exists a Y different from X such that Y belongs to the intersection of the epsilon neighborhood and A. So from that statement, sige, highlight ko siya. For all epsilon, there exists such that this guy. Ano yung sinasabi nung highlighted, or what can you discern from that, from those highlighted symbols there? Iisip ko kung words yung sasabihin ko, parang wala palang words dun sa highlight ko, no? Yes. All right, perfect. So yes is correct. That means X is a limit point of A. Kasi i-compare niyo siya dun sa definition. Dun sa ni-review ko na definition kanya, exactly ibig sabihin niyan, si X ay limit point ni A. And how do I write X being a limit point of A? It means X is a member of A prime. Okay? Tapos, kung member siya ng A prime, so definitely member na siya ng A bar. Kasi si A bar ay union ng A at saka A prime. Right? So if we are lucky that the element Y belongs to this guy, then we are sure that X is in A bar. However, merong isang case, hindi tayo sure na dito siya nakatira kasi union lamang yung nandun sa gitna ni Y. May slim chance, di pala slim, may chance na si Y ay nandito sa kabila. So I still need to consider the other case. But I want from that other case to get the same conclusion that X is in A bar. And actually, ito yung mas komplikado. All right. So case 2, Y is an element of the epsilon neighborhood intersection A prime. Okay. Now, so kung si Y ay element ng epsilon neighborhood at saka ng A prime, then ano yung pwede kong masabi? So pag mga ganito na medyo hindi ka na sure ano yung pwede nating gawin, alright? So kasi mula rito ang pwede mo namang masabi ay si Y ay element ng si X ay element ng A prime prime. Alright? Siya naman ay siya ay limit point ni A prime. Pero ano si A prime prime? Meron na ba tayong result na nagsasabi ng A prime prime ay equal kay A? I don't think so, right? Wala pa tayong ganong statement. Okay. So, ibig sabihin, wala akong magagawa. Hindi ko magagamit yung same trick as what we use from case number 1 because I don't know how A prime prime looks like so far. Wala pa yata tayong result na ganon sa ating handout or sa ating lecture notes. So, ibig sabihin, I need to be a little bit clever about this particular case. All right. So, tingnan natin. Dahil wala na akong maisip na susunod na gagawin, so gagawin ko na yung secret technique. Mag-drawing ka. Alright? So tingnan natin, ano yung nandito tayo. So si Y daw, halimbawa ito si Y, siya ay member daw ng epsilon neighborhood intersection A prime. So i-note ko dito si Y ay element ng A prime. Pero it is actually easier to visualize yung pagiging element niya ng epsilon neighborhood ni X. So kung nandito si X, tapos si Y ay element ng epsilon neighborhood niya, so ibig sabihin from X, posibleng ganito kahaba yung epsilon. Okay? Kasi nga si Y ay miyembro ng epsilon neighborhood ni X, meaning the distance between X and Y is less than epsilon. So parang ganito yung geometric interpretation niya. Of course, you can play around with the location of Y relative to X. Pwedeng andito si Y. So yung epsilon mo naman, pag ganito naman. All right? So, but that's fine. Without loss of generality, we can assume that after some reflections or geometric transformation, parang ito yung generic picture that we'll have. Okay? Now, what can I say here? Mm-hmm. Mm-hmm. Siguro may pupuntahan pala yung ni-note ko kanina, no? Na sabi ko kanina, yung preliminary statements dito, yung for all epsilon, together with this particular case implies that Y is a limit point of A. Hold on. Limit point ba siya ni A? O ni A? Limit point siya ni A prime. Tama? Let's see. Kailanganin ko ba yon? Hindi ko pala gagamitin yung definition ng pagiging limit point. Ginamit ko lang yung definition ng intersection. Alright, so I was thinking way over my head there. So Y is an element of the intersection. So definitely Y will belong to both sets. So kunin ko si Y ay element ng A prime. Okay? At bakit gusto kong mahugot yung Y element of A prime? Because when Y is an element of A prime, then sa kahit anong epsilon neighborhood around Y, may makikita ako ng mga elements ni A. Kasi remember, this means nagkukumpul-kumpulan sa paligid ni Y yung mga members ni A. Kasi ang ibig sabihin nito, si Y ay limit point ni capital A. So ibig sabihin, mag-drawing ako dito ng isang maliit na neighborhood, tawagin nating epsilon star neighborhood. Okay? Maraming elements ni A dito. Dun sa epsilon neighborhood na yan. Okay? Dyan sa epsilon star neighborhood na yan. So, ibig sabihin, geometrically, we are now seeing elements of capital A that belong to not just the epsilon neighborhood of Y, but also the epsilon neighborhood of X. That is, if we will choose epsilon star nicely, so that the epsilon neighborhood around X will contain the epsilon star neighborhood around Y. Right? Ano daw yung sinabi ko? So graphically, ang nakita natin dito, all right, lahat pala, yung mga elements pala ni Y, or may mga elements si A na nagkukumpul-kumpulan around Y. Kasi nga si Y ay element ni A prime. Derived, isa siyang limit point ni A. So sa kahit anong epsilon neighborhood ni Y, laging may mga nakatira na element ni capital A. Right? Excuse me. All right. And then, kung pipili ako ng small enough neighborhood, say an epsilon star neighborhood, then mapo-force ko yung mga elements ng neighborhood around Y that also belong to A na nandun din sa loob ng epsilon neighborhood na around X. Alright, so graphically, may mga elements dito ni A, so definitely yung mga elements ni A na yun nakatira rin dun sa epsilon neighborhood around X. Alright? So let's just formalize that statement. So then for any epsilon star greater than 0 with say epsilon star being less than the difference between ano kaya yung tamang epsilon star? Dapat siya ay mas maliit. So kung itong buo ay epsilon, so pipiliin ko lang na okay, wag lang siyang lalampas sa wag lang dapat lalampas dito yung epsilon star. Ayoko lang na makasama to sa epsilon star neighborhood. Kasi pag napasama to sa epsilon star neighborhood, halimbawa ito yung kunin kong epsilon star. Alright? Ibig sabihin may chance na yung mga elements na A dito magkukumpulan. Pero pag dito sila nagkumpul-kumpulan, yung mga elements na A, ibig sabihin nasa labas sila ng epsilon neighborhood ni X. So kailangan kong kulungin yung mga elements ni A na nagkukumpul-kumpulan sa paligid ni Y dun sa epsilon neighborhood ni X. Para masabi ko na, yung epsilon neighborhood din ni X nagko-contain din ng mga elements ni Y. So dapat gaano kahaba yung maximum na epsilon? Na epsilon star. So ibig sabihin, ayokong lalampas ng ganito kahaba or ng ganito kahaba yung epsilon star. All right? So I will choose epsilon star to be less than the minimum. Okay? Between what? Dapat mas maiksi siya dito. And that length is the distance between X minus Y. All right? Para hindi naman siya lalampas dito para mawala ng chance na nandito yung mga elements ni A na nagkukumpul-kumpulan dun sa epsilon star neighborhood ni Y. Right? Tapos ayoko rin naman lumampas dito, so kailangan mas maliit siya sa length na to. Gano'ng kahaba to, guys? Sige nga. Tama ba siya ay epsilon minus absolute value of Y? Tama ba? Yung buo kasi ay epsilon. Tapos, ito ay length ni X minus Y. So, ito ibig sabihin dapat ito ay epsilon minus length ni X minus Y. Okay? Pero gusto ko siya ay positive. So, lagyan ko pa siya ng absolute value doon para sure. Tama ba? So, na-visualize nyo ba yung mga pinagagawa ko rito? Bakit insistent ako na pumili ng maliit na epsilon star? Reaction, guys? Questions? Or do I need to repeat the analysis I did? Okay naman? Hoy, sumagot naman kayo. So I hope this is okay. Sige, pag wala nagtanong, I will assume that everything is okay. Yeah, yes, David.
Sir, medyo nalito po ako dun sa X minus Y po.
Alright, dun sa pagko-compute ng X minus Y. Pero yung idea naman ng ano yung gusto ko ano yung gusto ko kay epsilon star ay clear.
Hindi ko rin po ganun na-gets, sir.
Alright, sige. Ulitin natin from scratch. So, alright. Okay. So remember, ang gusto kong ipakita ay si X ay element ni A bar. Alright? Kaya lang, the best thing that we got so far, mula dun sa case number 2, is that si Y ay element ni A prime by definition of intersection. So alam ko si Y ay element ni A prime, ibig sabihin si Y ay isang limit point ni A. Right? Ibig sabihin, nagkukumpul-kumpulan yung mga elements ni Y, mga elements ni A around Y. The problem is that's not what we want. We want to show that X at least is a limit point of A para mabelong siya dun sa A bar. Katulad nung statement natin kanina. So gusto ko mapakita na nagkukumpul-kumpulan rin around kay X yung mga elements ni A. Pero alam ko lang, nagkukumpul-kumpulan yung mga elements ni Y sa paligid, yung mga elements ni A sa paligid ni Y. So, ang gusto ko mangyari ngayon ay kunin yung relation between X and Y. Baka naman yung mga nagkukumpul-kumpulan kay Y, pwede rin magkumpul-kumpulan around kay X. Yun yung kailangan kong ipakita ngayon. So, graphically, ganito yung mangyayari. Dito si Y. Alam ko, element siya ni A prime, okay? So sure tayo sa paligid ni sa kahit na anong epsilon neighborhood, sa paligid ni Y may mga nakatira na elements ni capital A. All right? Tapos alam ko rin si Y ay nasa epsilon neighborhood ni X. So ito si X. So ibig sabihin yung epsilon neighborhood na yan, pwedeng ganito kahaba. All right? Because the only requirement is that the distance between X and Y would be less than epsilon. All right? Tapos ngayon, gamitin ko yung Y being a limit point of A. So pag nag-drawing ako ng isang epsilon neighborhood, or kahit anong epsilon neighborhood, I can make it so small that it will be contained inside, okay? Contained inside the epsilon neighborhood around X. Pwedeng mas malaki, pwede ring mas maliit. But I'll consider the smaller ones, okay? Now, bakit gusto ko maliit? Kasi kung maliit yung epsilon neighborhood at mapapakita ko or mapipili ko siya to be inside the epsilon neighborhood of X, then yung mga elements ni capital A na naninirahan dito sa epsilon neighborhood ni Y ay pwede kong kunin as the elements of A that belong to the epsilon neighborhood of X. Kasi pag nagkataon, ibig sabihin, nagkukumpul-kumpulan din yung mga elements ni A sa paligid ni X. Kasi nga sa kahit anong epsilon, kahit paliitin mo yung epsilon, lagi kang may makikitang Y. Tapos si Y, may mga katropa yan. May mga kasama yan, may mga bit-bit yan lagi na elements ni capital A. So parang, pwede nyo tingnan si Y as parang mga ano yan, mga artista. Alright? So tapos ito yung mga candidates ngayong election, right? So, dahil yung mga artista ay limit point ng mga fans o ng mga tao, pagka nakapag-accumulate yung si candidate X ng maraming celebrities, all right? Yung mga celebrities na yon, habang lumalapit kay candidate X, kasama niya lumalapit yung mga fans niya. All right? So parang ganun yung analogy. So parang sila yung influencers na nagdadala ng mga tao ng mga possible na mag-i-influence ni ni element X. All right? So that means now the burden on me is to choose this epsilon star. Okay? Gusto ko mapakita na yung epsilon star na yan can be chosen para makuha ko yung gusto kong scenario na yung mga fans ni artista Y ay magiging parte nung rally ni candidate X. So parang ganun. All right? So parang ganun yung mangyayari rito. So, but mathematically speaking, what happens is we want those elements of A that accumulates around Y to be treated as the elements of A that accumulates around the elements X as well. Right? So ngayon, tingnan ko, paano ko mafo-force? Paano ko pipiliin yung epsilon star neighborhood na yan? The only requirement that I want is that the epsilon neighborhood around y to be a subset of the epsilon neighborhood around x. Okay, so yan yung gusto kong mangyari. Now, how can I guarantee that? Well, para mag-guarantee yon, gusto ko lamang gawin si epsilon star to be small enough. How small enough? I want it to be small enough na hindi siya lalampas. Okay, so ito si y. Ayoko siyang lalampas dito kay x. Kasi pag lumampas siya dyan, pag masyadong malaki si epsilon star, pag lumampas siya dyan, may posibilidad na yung mga elements ni hindi ko pala kailangan yon, no? Kasi dapat dito sa kabila pala yon. Baka yung pala yung nalilito si David. Kasi dapat yung epsilon, dapat okay lang na nandito pala sila as long as that is within the epsilon neighborhood. Ang ayoko ilalampas siya dun sa x minus epsilon. So ayoko na lumampas ito dito. Alright? So, but basically, paano ko siya nga, let's see. Well, hindi ko naman kailangan kunin yung pinakamalaki. Kailangan ko lang may mapakita. So, if epsilon is smaller than the distance between x minus y, ito yung distance mula kay x minus y. So, ibig sabihin yung epsilon star neighborhood ay hanggang dito lang. Or at most hanggang dito lang. Hindi siya lalampas kay x. So, sure ako, nandun pa rin siya sa kanan ni x. So, kaya okay lang yan. That's small enough. Pwede pa siyang lumaki ng konti. Pwede pa siyang hanggang dito. As long as hindi siya lalampas sa x minus epsilon. Alright? Pero I just need to guarantee it to be smaller, to be small enough. Alright? So ayoko siyang lumampas ng x minus y. Then ayoko rin siyang lumampas dito, definitely. Kasi pag yung epsilon star ay mas mahaba dito, sa length na yan, ibig sabihin, posibleng nandito yung mga hakot ni Celebrity Y. Alright? Wala sila sa epsilon neighborhood ni X. Gusto niya dalhin niya to na malapit kay element X. Alright? Pero gaano ba kahaba? Ito. Yung buo ay epsilon. Ito ay distance X minus Y. So this guy is the absolute value of epsilon minus the distance between X and Y. I don't think kailangan ko rito ng absolute value symbol na. Alright? Kasi nga, mas malaki si epsilon sa distance ni x minus y. Okay? So is that better? Is that a better explanation? Okay.
Yes, sir. Thank you.
All right. Thank you. So, okay. So if that is the case, then okay. So ibig sabihin yan, there exists a C not equal to y such that Z belongs to the epsilon star neighborhood of y intersection A. And again, I was able to do so because si y ay limit point ni A. So yung definition ng limit point kanina, in-apply ko naman kay y. So ibig sabihin, may makikita akong element na z, different from y, na si z ay nasa epsilon neighborhood or nasa epsilon star neighborhood ni y at saka na kay A. Kasi ngayon, si y naman yung limit point. But since with our choice of epsilon star, the epsilon star neighborhood of y belongs to the epsilon neighborhood of x. All right? Ito yung bakit naging choosy ako sa pagpili ng epsilon star. But because I really want epsilon star to be small enough so that it is properly contained in the epsilon neighborhood around x. Thus, we can say that z also belongs to the epsilon neighborhood of x intersection A. Kasi itong intersection na to ay subset ng intersection na ito. Alright? And so what do we have now? So go back to the preliminary statement for all epsilon greater than 0. There exists a z in the epsilon neighborhood of x intersection A. And again, z is not equal to y, and y is not equal to z. So, actually, hindi pala siya enough. Dahil ang distance between x minus y, ang distance between y and z ay epsilon star, mas maliit siya sa absolute value ni x minus y, ibig sabihin walang chance na si z ay maging equal kay x. Alright, with z not equal to x. Alright, kaya medyo kailangan ko nga to para si z sure ako hindi siya maging equal kay x. So therefore, since all of those requirements for being a limit point is met, then we can say that x is a limit point of a as well. Okay, kasi yung mga z's naman magkukumpul-kumpulan din around sa kanya. Si z siya yung mga fans ni element y. All right, so nagkukumpul-kumpulan na rin sila around candidate x now. But if x is an element of a prime, it follows that it is an element of the closure, right? So in either case, in case 1 and in case 2, we have shown that x is an element of the closure. Then that means the closure is indeed a closed set. All right? Kasi nga remember, si x ay arbitrary limit point ni a bar. Limit point siya ni a bar. Tapos napakita natin na kahit ano pa mangyari, si x ay na kay a bar. So ibig sabihin, laman ni a bar lahat ng kanyang mga limit points. So a bar is indeed closed. All right? Is that good? Okay, but we are not yet done because we need to prove another statement. The second statement is that it is the smallest. The closure is the smallest closed set containing A, right? So to show that, I'll do a proof by contradiction. Now we suppose, for the sake of contradiction, that there exists a set B, a closed set B. Kasi ang sabi nung second part in theorem, siya yung pinakamaliit na closed set. So kunwari, meron pang closed set na nagko-contain kay A, pero hindi siya equal pero siya ay proper subset ni A bar. Okay? So, ibig sabihin, merong mas maliit na set B, mas maliit kasi subset siya ng closure, right? May isang set na mas maliit kay closure na close din na nagko-contain kay capital A. Alright? So, gusto ko ipakita na imposible na magkaroon ng ganyang set. Closed set na B na proper subset ni A bar na nagko-contain kay A. Alright? So, saan ko kaya hugutin yung contradiction? Now, let's see. What can we say about this guy? B is closed at saka proper subset siya ni A bar. Kung i-drawing kasi natin yan, ito si A. Tapos remember yung A bar ay A union A prime. So ibig sabihin mas malaki si A bar talaga. So ito si A bar. Oh, sorry, ito si A bar. Tapos meron daw set B na ito si set B. Ibahin natin yung kulay. Kunwari, merong set B na ito. Ito yung set B. So kung ganyan yung itsura ng mga sets natin, ibig sabihin, merong mga elements, tawagin nating X, or merong mga elements katulad ni X na to, na wala kay B, wala rin kay A, pero na kay A bar. Alright? So ano lang ba yung possibility na kay A bar siya, pero wala siya kay A? So ibig sabihin, si X dapat nagbibelong kay A prime. Kasi na kay A bar siya. A bar is A union A prime. Okay? So ibig sabihin, may makikita tayong element X ni A prime na wala kay B. Kasi nga gawa ng pagiging proper subset ni B ni A bar. Okay? So that means, there exists an X in A prime such that X is not in B. Okay. So may makikita tayo for sure na element ni A prime na wala kay B. Merong limit point na wala kay B. So essentially kasi sinasabi natin ay may mas maliit na set sa A bar. Si A bar laman yan na lahat ng limit points ni A. So merong mga limit points si A na wala kay B. Alright? So now, what can we say from here? Oh, so this means that, okay, so gamitin ko yung definition ng pagiging limit point ni X ni A. So this means for all epsilon greater than 0, there exist, gawin ko yung implication na lang. For all epsilon greater than 0, there exists, say, a y not equal to x, such that y is an element of the intersection of the epsilon neighborhood around x and A. Right? So definition ng pagiging limit point. However, si A ay nasa loob ni B. So ibig sabihin kung si Y ay naninirahan sa intersection na to, so ibig sabihin si Y ay nakatira rin sa intersection na ito. Alright? Because the intersection of the epsilon neighborhood in A is a subset of the intersection of the epsilon neighborhood and B by virtue of A being a subset of B. Alright? Tapos by simplification, dahil member siya ng intersection, nakatira siya sa parehas na to. So that means, let's see. Mako-conclude ko pala ay Y element of B. Pero gusto ko makonclude ay si Xi element ni B. Lifeline guys. Bakit nalito ako rito? Dapat mas madali itong proof na to. X element of A prime, blah, blah, blah. Okay. Okay. Iba pala yung gusto kong conclusion. Sige nga. Ayan, naisip ko na. So, ano yung pwede kong conclusion from here? Ayan, highlight ko na naman. Guys, tulungan niyo ako. So what does the highlighted statement say? Yes, David?
Meaning ba niyan, sir, pwedeng maging Y is an element of B po kasi intersection siya?
Almost. Hindi si Y. Gusto mo sabihin Y element of B. Yun ba yung gusto mo sabihin?
Apo. Yun ba, sir?
Yeah, that's correct. That will follow. Yun yung una kong ring inisip. Kaya lang parang walang pupuntahan. Kasi ang gusto ko, mapakita na si X ay element ni B. Kasi meron tayo sa assumption na X not element of B. So yun sana yung gusto kong maging contradiction. Right? So kaya lang kung Y ay element ni B, which is right, that logically follows from the previous line. Kaya lang parang paano ko mapapakita ngayon na si X element of B? Kasi wala naman makakontradict yung Y element of B. Sige, Ayesa, standby ka lang. Any other volunteer aside from Ayesa? But nice try, David. Let's see. Ayun na yun, guys. Na-highlight ko na. Translate nyo lang into English yung naka-highlight. Hindi literal na translation sa English. Ano yung ibig niyan sabihin? Parang ang cool na natin ngayon, no? Kaya nating mag-usap-usap ng puro symbols lang, walang mga words na kasama. All right. But that speaks volumes for us, right? Anyone? Sige na nga, Ayesa, ano nga uli yun? Yes, Ayesa is right. Ito uli, gamitin ko lang yung definition ng pagiging limit point. Thank you, Ayesa. That's perfect. X is a limit point of B. All right? Kasi nga, sa kahit anong epsilon greater than 0, may makikita ang member ni B na nagkukumpul-kumpulan around the epsilon neighborhood of X. So, ibig sabihin si X ay element ni B prime. Limit point siya ni B. Alright? Pero anong alam natin kay B? Assumption natin ay si B ay closed. So kung si B ay closed, ibig sabihin laman niya lahat ng limit points niya. So ibig sabihin, dahil si X ay limit point ni B at si B ay closed, so ibig sabihin si X ay element ni B since B is closed. Okay? And this is a contradiction because we have assumed earlier that X must belong outside of B. And yet now we are claiming that X is an element of B. Therefore, walang nag-exist na ganitong set B. Kasi nga pag may nag-exist na ganyang set B, then we will find an element X that are both in B and not in B. Right? So therefore, A bar is the smallest closed set containing A. All right? End of proof. Okay? Medyo napahaba yung proof natin for just one proof, right? And how many pages? 1.5 pages. Medyo inabot tayo ng 1 hour yata rito. But that's fine. At least we're going through all of the details and I hope you guys got the idea paano siya ginagawa. All right? It's not for you to repeat the proof or to memorize the proof, but to understand ano yung thought process natin dun sa proof. All right? That's why I also decided not to write a proof for this one na typewritten na para mabusisin natin siya isa-isa. All right? Now let's move on. If you don't have any questions, medyo kailangan ko tong hapitin ng konti. Pero let's see. Theorem 14. Yung Theorem 14 is a nice characterization or a nice it's a result that kind of relates open and closed sets. All right? Ayun pala, kapag ka siya ay open, hindi necessarily na hindi siya closed. Pagka ang isang set ay closed, hindi ibig sabihin na siya ay hindi na open. Merong mga sets na open and closed at the same time. Alright? Example ay empty set at saka set of all real numbers. Remember, hindi natin define yung pagiging closed as a set is closed if and only if it is not open. So hindi ganon. Hindi ganon natin siya define. Hindi siya katulad ng pinto that is either open or closed. Right? So may mga sets na open and closed at the same time like R. All right? Or like the empty set. Makikita natin yun later after we prove Theorem 14. And actually, there are also sets that are neither closed nor open. Alam mo, itong interval na to. This interval, ang tawag natin dyan sa algebra ay half open, half closed sets, all right? But essentially, this is not open, all right? Kasi pag pumunta ka kay element B, may makikita kang epsilon neighborhood ni B na hindi properly contained sa interval na yan. So hindi siya open. Pero hindi rin siya closed kasi hindi niya nilalaman lahat ng kanyang mga limit points. Kasi si A ay isa niyang limit point. Pero si A, wala dun sa interval. So ito ay isa namang example na hindi siya open at hindi rin siya closed at the same time. So basically, wag niyong sasabihin na kapag ka siya ay hindi open, ibig sabihin closed na siya kagad or vice versa. Alright? Being not open is not being closed in mathematics. Alright? So kaya be careful with the terminologies here. Okay? Pero meron silang relation pa rin. Yun yung nasa Theorem 14. A set O is open if and only if its complement is closed. So si O ay open kapag ka yung complement niya ay closed. And vice versa. Ang isang set ay closed if and only if yung complement naman niya ay open. Alright? Ipoprove ko yung kalahati and try to write the proof for the other one. Let me put a star on this. Okay? Para maalala ko na inassign ko siya sa inyo. You can find the standard proofs of these statements in books or in blogs or internet materials, alright? But I want you to try to play around the definition ng pagiging closed at pagiging open para ma-practice nyo rin sila, okay? I'll prove the first statement, but the first statement is a biconditional one, so we'll need a two-part proof, okay? So proof, I'll start with the forward direction. So I will assume that the set O is open. And we want to show that the complement is closed. Okay. Yan yung target natin. Assume natin na siya ay open. Gusto kong ipakita siya ay closed. Alright? Gusto kong ipakita na siya ay closed. So, ibig sabihin, kailangan mapakita ko, para mapakita na siya ay closed, kailangan mapakita ko na lahat ng limit points ni O complement ay na kay O complement. Alright, yun yung pagiging closed. So, I will assume X be a limit point of O complement. Alright? Then this means, alright, and then I'll use a proof by contradiction here. I'll suppose that X is not in O complement. Alright? Tinry ko yung direct proof. Mukhang mahirap yung direct proof na ipakita na si X ay magbe-belong kay O complement. Ang alam ko lang si X ay limit point ni O complement. Ang goal ko mapakita ni si X ay na kay O complement, but the direct path might be difficult. So now I'm trying proof by contradiction. So suppose si X wala kay O complement. Kung wala siya kay O complement, definitely siya ay na kay O, right? That this X is in O. Pero ano ba si O? Si O ay isang open set. So dahil si O ay isang open set, so that means, sulat ko lang, since O is open, then there exists an epsilon greater than 0 such that the epsilon neighborhood around X is a proper subset of O. Alright? So definition ng pagiging open ni O. Open siya kung lahat ng points niya ay interior. Ang isang point ay interior kapag meron siyang epsilon neighborhood, and watch out for the quantifier, meron siya. So there exists an epsilon neighborhood that is properly contained in O complement. Okay? Pero, dahil itong epsilon neighborhood na to ay properly contained kay O, ibig sabihin, yung epsilon neighborhood intersection O complement will be empty. Do you agree? Kasi nasa loob nga siya ni O eh. So ibig sabihin, wala siyang ka-intersection sa O complement. Pero ito ay contradiction. Bakit siya contradiction? Anyone? Hoy guys, bakit siya contradiction? Tatampo na ako, wala nang sumasagot eh. Contradiction siya kasi sabi natin si xi limit point ni O complement. Ano yung pagiging limit point? Limit point siya kapag sa kahit anong epsilon greater than 0, etong intersection na to ay may member na different from x. Right? So for all epsilon greater than 0, this intersection will have a member different from x. Yun ay dahil inassume natin si x ay limit point ni O complement. Okay? Pero yung pagiging open ni O gave us an epsilon kung saan imposible na magkaroon ng member yung intersection na ito. And that is the contradiction. Alright? So, hindi siya magiging limit point ni O complement kasi nakakita tayo ng epsilon neighborhood na walang laman na element ni O complement. So, because this means, alright, this means X is not a limit point of O complement, which is a contradiction to our supposition that X is a limit point of O complement. So therefore, we must say that, okay, X must be an element of O complement. Okay? And so, since X is an arbitrary limit point of O complement, and we have shown that that arbitrary member lives in O complement, so O complement is closed. All right, which does half of our job. The other direction, yung pakabila naman, we'll assume that O complement is closed. And we want to show that what? We want to show that O is open. Okay? And I think a direct proof here will suffice. So gusto natin mapakita na si X ay na si O ay open. Kailangan ko lang makakita ng epsilon neighborhood around of O. Okay? So what can we say here? I think I can use the definition of pag. So let's see. Okay, so here I'll take. Tama nga ba? Kaya ko nga ba ito ng direct proof? Napaisip ako bigla. So let's see. Let X be an element of. Okay, maybe I can do it this way. Let X be an element of O. Then X is not a limit point of O complement. All right? Bakit si X ay hindi pwede maging limit point ni O complement? Kasi inassume natin na si O ay closed. Ibig sabihin lahat ng limit points ni O complement ay na kay O complement. Dahil si X ay inassume natin to belong to O, then X is impossible to be a limit point of O complement. Tama? At dahil hindi siya limit point ni O complement, then there exists an epsilon greater than 0 such that the intersection of that epsilon neighborhood around X and O complement is empty. Okay? Kung empty ang intersection na yan, ibig sabihin yung intersection ni X, ang intersection ng epsilon neighborhood ni X at saka ni O will be, actually hindi pala, hindi intersection with O. Ibig sabihin yan, ito ay proper subset ni O. Dahil yung intersection na yan ay empty, tapos itong epsilon neighborhood naman na yan ay non-empty. Alright? So, ibig sabihin, kaya sila walang intersection kasi yung epsilon neighborhood na yan ay properly contained kay O. Kaya pwede kong sabihin itong subset relation na ito. So that means, alright, for any member of capital O, we have found an epsilon neighborhood that is properly contained in the set O. Okay? So therefore, indeed, we can say that O is open. All right. And the remainder of the proof is left as an exercise. Yun naman yung if F is closed if and only if F complement is open. All right. So yun naman yung pwede nyong paglaruan. Okay, questions? Nalata nyo bang medyo nagmamadali ako? In-expect ko matatapos ko ngayon yung module, yung lecture notes 1. Plus, I can start a little bit with the lecture note 2. Pero yeah, that's fine. But let me know if you have questions with the previous proof. Okay, so if none, diretso na tayo sa Theorem 15. Theorem 15 naman ay katulad ng Theorem 12. Pero ito ay para sa mga closed sets. Balikan natin yung Theorem 12. So ito yung Theorem 12. Napanood nyo yung proof nito dun sa recording. The union of an arbitrary collection of open sets is open, and the intersection of a finite collection of open sets is open. Alright? Dahil ngayon, natutunan natin ano yung relation between open and closed sets, mas madali nang i-prove yung Theorem 15. Though you could have proven Theorem 15 using similar arguments or analogous arguments as what was used in Theorem 12, kaya lang kung matatandaan niyo yung proof ng Theorem 12, napaka-mabusisi. Kaya I'm a little bit thankful na hindi ko siya kailangang ulitin sa klase. Nagawa ko na siya last semester, hindi siya masayang gawin. Alright? Kasi napaka-mechanical ng proof. Alright? Pero ngayon, hindi na ako gagawa ng analogous argument to that proof para lang ma-prove yung theorem 15. I can capitalize with theorem 14. Okay? And how will I do that? I'll illustrate that for the proof of part 1. I leave the the proof of part 2 to you guys. Okay? Prove natin yung part 1. So the union of a finite collection of closed sets, typo, is closed. All right? So kukuha muna ako ng finite collection ng closed sets. So let F1, F2, until Fn be closed sets. Tapos gusto nating ipakita na yung union ni F1, F2 hanggang Fn ay closed. Alright? So paano ko siya papakita? Gagamitin ko yung theorem 12. Oops, ba't sumama siya? Ayan. Bakit siya dumikit? Anyway, hopefully nakikita nyo pa yung theorem 12. Okay? So by theorem 14, F1 complement, F2 complement, until Fn complement ay open. Right? Ang complement ng closed ay open. Alright? So yun yung ginamit ko rito. So ito yung mga open sets. And then look at theorem 12.1. The union, part 2. The intersection of a finite collection of open sets is open. And what do I have now? I have a finite set of open sets. So kunin ko kaya yung intersection nila and let's see if that will help me. All right. So by theorem 1.12, the union F1 complement, Fi complement, I going from 1 to n is, hindi pala union, ang kulit, intersection is closed. Is open. Nangyayari sa akin. Okay. Meron tayong finite collection of open sets. Kinuha ko yung intersection ng mga open sets na yon. Sabi ni theorem 1.12.2, ang intersection ng finite collection ay open. So meron ako nito. Tapos ang gagawin ko ngayon, kukunin ko yung complement nito. Kasi ang complement nito daw ay closed. Kasi nga siya ay open. Right? So that's what I'll do here, or that's the strategy here. I'll take the complement. So now, I'll take the complement of the intersection, 1 to n. Kunin ko yung complement niyan. Okay. Tapos, in-expect ko na yung complement na yan ay closed. Kasi nga, ito ay open. Pag kinuha ko yung complement, magiging closed. Alright? But I'll use De Morgan's law para dito. So, hello, Math 101. So, ito yung magiging union. I going from 1 to n ng F, I, complement. Pero ang complement ng isang set ay yung sarili niya. Alright? And again, we know by theorem 14 that this is closed. Right? Kasi siya ay complement ng open. So siya ay closed. And what do we have now? We have shown that the union of a finite collection of closed sets is closed, which is exactly part 1 of the theorem. Okay? And then you can imagine the same thing or the same argument will be sufficient to prove the second part. So the rest is an exercise. Okay, guys? Any questions about that? Kaya nyo bang i-prove yung part 2? I believe you can.
I think nakikita ko na, sir, paano yung part 2 po.
All right, great. Thank you, David. Yeah. So, tapos nakita nyo paano, ang laki ng shortcut. Kasi pag kinompare nyo tong proof na to dun sa proof na ng theorem 1.12, super haba yung theorem, ng proof ng theorem 1.12. Alright? Pero thankfully, na-discover na natin na ang complement ng closed ay open at ang complement ng open ay closed. So, yeah, mas madali na para sa atin ito. Okay. Now, all right, tapos na yung section 1.8. last na. And this last section, puro definitions na lang naman to. So I guess we can still finish it for today. All right? Though baka info overload na. So parang ano na lang to, cool down na natin to. Tatlo na yung malalaking theorems na na-prove natin. So ito na yung magbabanlaw na tayo. All right? So mga definitions na lang to. Okay, so first definition, ang isang set ay perfect kapag ka siya ay closed at wala na siyang isolated points. Remember, ang isang set ay closed kapag laman niya na lahat ng kanyang limit points. Pero hindi natin sinabi na lahat ng elements ng isang closed set ay limit points. Ang sinabi lang natin, kapag ang isang set ay closed, laman niya na lahat ng kanyang mga limit points. Pero posible na merong mga laman si set P na hindi limit points. Or in other words, baka merong mga isolated points doon sa loob ng isang closed set. Pero pag nagkataon na yung closed set ay walang laman na isolated points, ibig sabihin katulad siya ng mga closed intervals na closed na, tapos lahat ng laman nila ay limit points pa, so ibig sabihin ang tawag natin sa set na yan ay perfect. Okay? So at least dito sa Math 155, meron tayong definition ng pagiging perfect. So pag sinabi nyo na perfect kayo, dapat wala kayong isolated points at saka dapat closed kayo. Alright? So, yon. Tapos, ano naman pag sinabi nating disconnected set? Okay? Pero bago natin ma-define kung ano yung disconnected set, tingnan muna natin ano yung separated set. Pag meron tayong dalawang non-empty sets, sasabihin natin sila ay separated kapag yung closure ng isa, intersection yung kabilang set, dapat ay empty. Alright? So ibig sabihin yung closure ni A, intersection B, at yung A intersection closure ni B, dapat ay parehas empty. So ito ay mas strong na condition kaysa sa pagiging disjoint. Kapag ang isang set ay disjoint, baliktad. Kapag ang dalawang sets ay separated, automatic sila ay disjoint. Kapag ang dalawang sets ay hindi disjoint, walang chance na sila ay maging separated. Pero kapag ang dalawang sets ay disjoint, hindi necessary na sila ay separated. So ibig sabihin, mas malaking condition or mas strict na condition yung separated kaysa sa pagiging disjoint. Okay? Bakit? Kasi halimbawa, itong set na to, set 1, 2, at saka set 2, 3. Okay. Itong dalawang sets na to ay disjoint kasi wala silang common elements. Alright? Kasi nga, ang posible lang nilang intersection ay si 2, kaya lang si 2 ay wala dun sa open interval. So, tawagin natin tong A, tawagin natin tong B. Pero silang dalawa ay hindi separated. Okay? Bakit sila hindi separated? Kasi, kunin mo yung A intersection closure ni B. Ito ay magiging 1, 2 union, intersection the closed interval 2, 3 kasi closed interval 2, 3 ang closure ni B. Alright? But this is the set containing 2. Alright? So, ibig sabihin si A at saka si B ay hindi separated. Kasi dapat maging yung boundary nila o yung closure nila o yung closure ng isa dapat ay disjoint dun sa kabila. Kung i-drawing nyo tong intervals na to, ganito yung magiging itsura. Andito si 1, so open yan. Andito si 2, ito yung set A. Tapos si set B naman ay andito 2 hanggang kay 3. So kung titingnan niyo yung picture, hindi talaga sila separated. Kasi ang nangyari dito ay nagtatouch yung boundaries nilang dalawa. Parang ganun yung idea. Unlike the open interval 2, 3 and the open interval 1, 2, alright? Kung saan pag ginraph mo yan, ito yung 1, 2, ito yung 2, 3. Okay? Merong isang number na nag-act as a boundary between those two sets. Merong isang real number na nagse-separate dun sa dalawang sets, and that is the number 2. All right? Kasi tingnan mo, ano yung closure nito? Ang closure nito ay closed interval 1, 2, intersection with the open interval 2, 3, that will be empty. The closure of the open interval 2, 3 is the closed interval 2, 3. Intersection, the open interval 1, 2, that is also empty. So yung closure, yung A bar intersection B at saka yung A intersection B bar ay parehas empty. So itong dalawang open intervals na to ay separated. And visually speaking, because there is a real number that separates the two. Okay. In our counter example earlier, the number 2 does not separate the two intervals because si 2 ay nagbebelong kasi siya dun sa kabila. Alright, parang siya nga yung naging bridge between the two intervals. Okay? So kaya hindi porket sila ay disjoint, ibig sabihin sila na ay separated. So medyo mas mabigat yung separation kaysa sa pagiging disjoint. Pero of course, kung meron kang dalawang sets na disjoint, hindi talaga mag-work yan. Pag meron kang dalawang separated sets, ibig sabihin sila dapat ay disjoint talaga. Okay? Now, we say that a set E is disconnected kapag pwede natin siyang masulat into two separated sets. So, ang isang set ay disconnected kapag pwede mo siyang hatiin sa dalawang separated sets. Okay? So, yun yung idea ng disconnected. Tapos kapag hindi siya disconnected, siya naman ay connected. All right? And see how very tedious we are with our semantics over here. Yung pagiging connected, kailangan kong i-define pa to be not being disconnected. Kung hindi siya disconnected, siya ay connected. Pero naging careful tayo sa open at closed. Wala tayong sinabi na pag hindi siya open, siya ay closed kasi hindi nga ganun yung storya. I forgot to mention that earlier. Bakit ko nasabi na si R at saka si empty set ay parehas open at closed? I think when we discussed open sets, nasabi na natin na open si R. Alright? Kasi any epsilon neighborhood around any real number is contained in R. So, easy. This is open. Okay? Pag kinuha mo yung complement niyan, okay, which is the empty set, so ibig sabihin ito ay dapat ay closed. So, close si empty set. Pero remember, isa rin si empty set dun sa mga examples natin ng open sets. So here we have seen that the empty set is both open and closed. Tapos pag kinuha ko yung complement ni empty set, which is R, that should be closed. Kasi nga, complement si R ng isang open set. So ibig sabihin siya ay closed. So essentially, R is both open and closed at the same time. All right, so sila yung mga quick examples ng mga sets na parehas open and closed. Sorry, nakalimutan ko lang siyang banggitin kanina. Okay. All right. Yan, malapit na lumabas si Gordon Ramsay. So, last na, boundary point. So, ang isang set ay boundary point, ang isang real number ay boundary point ng isang set kapag kahit anong epsilon neighborhood ng element na yon ay may mga elements ni A at saka may mga elements ni A complement. Kaya siya pwedeng tawaging boundary point. Well, that's easily illustrated. Madaling maintindihan kung bakit ganun yung definition niya. Okay. Halimbawa, meron akong set A. Visually speaking, I know what the boundary of this set is. Kahit layman, makasalubong nyo sa kalsada, sabi mo, sir, ano yung boundary ni A? Sabi niya, yan yung may kulay. Yan. Isa yung boundary point. Okay? Bakit siya naging boundary point? Sabihin sa'yo ng mama na nakasalubong mo, basta kasi it makes sense that that is a boundary point. Pero sa math, hindi tayo pumapayag ng ganon. Kailangan natin mag-define. And paano na natin siya ma-define in terms of epsilon neighborhoods? Well, magtingin ka ng epsilon neighborhood around that point. Gaano pa kaliit or kalaki ang epsilon neighborhood na i-drawing mo? Yung epsilon neighborhood na yan ay may mga members galing kay A at saka mga members na galing din kay A complement. And if you will be able to do that for any epsilon neighborhood, however big or small the epsilon neighborhood is, lagi na ang tawag natin dun sa point na yon ay boundary point. Okay? So kapag ka lahat ng epsilon neighborhood niya ay nagko-contain ng elements ni A at saka elements ni A complement, then we say that a point a set A is a point A is a boundary point of the set A. Tapos pag kinolekta nyo lahat ng boundary points ng isang set, ito yung notation natin sa kanya. Okay. This is the boundary point, the set of all boundary points of capital A. So sige nga, mabilis. Sorry, overtime na. Pero mabilis. Quick bonus points. Ano ang boundary points ng closed interval AB? Sige nga. Come on, guys. Kung hindi pa nag-recite, sayang. Quick points. Ano yung boundary points ng AB, ng closed interval AB? Michelangelo, A and B? Yeah, that's right. Naunahan ka, sorry, Teresa. Ito naman ang para sa'yo, Teresa. Ano ang boundary points ng open interval AB? Therese, gusto mo mag-try? Sige, kung ayaw ni Therese, anyone? Na hindi pa nag-recite, sayang yung points. Boundary points ng open interval AB. Come on, guys. Going once. Jericho. Yeah, that's correct, Jericho and Trisha. Yeah, A and B pa rin. Okay? Kasi kapag ka nag-drawing ka ng epsilon neighborhood around A, sure ka na laging may mga elements galing sa open interval at galing sa labas ng open interval. Okay? How about this one? R. Ano ang boundary points ni R? Boundary points ni R. Sayang, pampa-homework ko na to sana. Lahat pala hindi ko na pinap-quiz, ano? But anyway. Si R ay walang boundary points, tama? It makes sense na wala siyang boundary point. Yeah, that's right, Jericho. Kasi nga, pwede mong tingnan, kaya pala siya unbounded kasi wala siyang boundary points. But technically, the reason why it is not a boundary point ay kasi wala kang makikitang element na yung epsilon neighborhood ay merong elements ni R at saka elements ni R complement. Kasi ano yung si R complement? Ang R complement ay empty set. So, impossible na ma-satisfy mo itong second conjunct dun sa definition ng boundary point. Okay? In the same manner, the empty set doesn't have any boundary point because it doesn't have any element at the in the first place. All right? And pasok na, Gordon. So yeah, finally, we're done with lecture notes 1. We're done with, and then we're done with chapter 1. Okay? At dahil dyan, meron na tayong problem set which will cover chapter 1. I think I promised to give it to you on, when? Thursday? Sinulat ko yun dito. Bakit nawala? Alam ko sinulat ko talaga yun. But okay, thank you, Michael. Yeah. So I'll give it to you on Thursday, and then the deadline, I think, ayan. Sakto. Hindi ko yan hinanap. Ni random scroll ko lang siya. So, and then the deadline would be Wednesday next week, all right? Coverage would be Unit 1. Okay? Any questions? Let's see, yes. Okay? So if there are no questions, tama ba? Yes, saka si David lang yung sumagat verbally. Okay, so if that's the case, then thank you guys for joining me today. Enjoy the rest of the day, and then let's see each other again on Thursday. Bye, everyone.
Thank you po, sir.
All right, welcome. Na-record ko ba, guys? Yeah. Luckily, na-record ko.